In winter, we often spread salt on our roads to melt ice and snow. The reason why this works is that the freezing point of a solvent decreases as the concentration of solutes increases. That is, the higher the solute concentration, the lower the freezing point of the solution. In this experiment, we're going to examine the freezing point depression using an organic solvent, lauric acid. We're using lauric acid because it has a melting point above room temperature, so we can heat it up to melt it and then let it cool down to room temperature and observe its freezing point. Then we'll add an unknown solute and measure the freezing point again. We can then compare the freezing point of the solution to that of the pure lauric acid. And then we can perform a calculation to identify the molar mass of the unknown. So suppose we have a liquid and we're gradually adding energy to it in the form of heat. What do you expect to happen? Well, we expect the temperature to go up. And initially, that is in fact what we would see. We would see the temperature increase. But at some point, the temperature stops increasing because we've gotten to the boiling point. And at the boiling point, as we add heat, the temperature of our liquid is not increasing. Instead, we see a constant temperature. And during that time, the liquid is boiling to the gas phase. Now, once we've finished boiling everything, if we continue to heat, then the temperature of the gas will go up again. In this experiment, we're going to be doing the opposite. Instead of adding heat, we're going to be removing heat. And so we're going to have a curve that looks similar to this with three separate portions. But instead, we're going to have heat removed. And so we're going to have, initially, the liquid temperature is going to drop. Then, as we start to freeze, as we remove heat, we're not decreasing the temperature, but we are instead freezing the liquid. And then, after we've frozen everything, then the temperature starts to drop again. So we're primarily going to be concerned with this portion. We want to see some data where the temperature is dropping initially. Then we want to see a smoother portion. And then we want to see some temperature dropping again. Now, once we put the solute in, we will not have the same temperature that the flat portion is at. We will instead have a depression of the freezing point. So it will be some value lower than that. And again, we'll have three temperature regimes, a downward trend, a flat portion, and another downward trend. And it's the difference between these two freezing points that is then the freezing point depression. And the amount of that freezing point depression will depend upon the solvent that we have, which in this case is going to be lauric acid, and on how much solute is dissolved. It does not depend on the identity of the solute. It only depends on the total amount of solute that we have present. Let's talk about safety. Both the lauric acid and the unknown are irritants. If you spill any of either, ask your instructor or teaching assistant for assistance. In addition, both of them are flammable. Keep them away from heat sources.